See if that worked. It did? Awesome. Okay, so we're on page 70 and we're talking about a farmer's eggs. All right, what's one of your givens? Go ahead, Pearson. What's one of your givens, Luna? Good. Another given? Viv? Thanks, Pearson. Someone's car pickup today?
Alex and Brody.
Okay. That's sus. Yeah, that's what it is. It's not sus. All right. So 1,250 eggs, puts 30 eggs on each tray. How many egg trays does she need to hold all the eggs? What kind of math does this sound like, kids? What kind of math? Kaylin? Division. So let's just set it up. I'm going to have you do it for homework. Don't. If it's already done, you could check it with a calculator. So your number model should be what, Carolina?
It should be, the dividend is 1,250, and then the divisor is 30.
Good. Great use of math vocabulary. I heard you say division, dividend, and divisor. All right. Is it possible you'll have a remainder? And then Carolina, what would you do? Would you throw the eggs on mischief night at someone's house or just save the extra eggs? Yeah, never do that. All right, good. So number 3 is all good. I need a reader for number 4, the supermarket. Wait, we did this one.
Yeah.
We Rupered that one. All right, let's go. All right, how about I give you the answer for number 4? You could check to see if it's right. It was $45 altogether. 45. You just Rupered it? You never did the math? All right, who thinks they know math step 1? Lauren. 18 times 40. We could put that in parentheses. What was the next step? Ridley?
18 times 40 divided by 16.
Divided by 16. Oh, I do remember talking about this with you guys. And then the last step is what? Luna?
Times $1.
Times $1.
10.
Well, is anything going to change mathematically when you times the number by 1?
No.
It's always back to that number, right? Okay. Okay, great job. I think we already did the charitable one. Did we do the length of the rectangular board one on?
No, we didn't do it. No.
All right, let's go over. Let's do this one. Let's go over here, kids. Number 7. Could I have a reader, please? Let's do Alex. Okay, do you guys remember what the formula for area was? We talked about the other day. Area of a rectangle is what, Declan?
It's length times width or base times height.
Good. Area equals L times W. Area equals base times height. And it's always expressed in units. What? Units squared. Right? And this one is centimeters, so it's cm squared. Right? These are like the givens, right? These are some of the givens. So I would like to do, whenever it starts talking about shapes and areas, I like to do a draw. So let's do a draw for this. And it's a rectangular board. So what's the first shape I want to draw? I'm gonna see some hands up. What am I gonna draw, Lauren? Let's just draw a rectangle. All right, I got a rectangle and it says it's 10 centimeters longer than it is wide. But then it tells you how wide it is. How about that? It's like a puzzle. So it says it's 10 centimeters longer than it is wide, and we know the width. All right, Colin, you with me? So what is the width? What does it say the width is? Huh?
26 centimeters.
Yeah, so let's put 26 here and 26 here. That'll be the width. And it says it's 10 centimeters longer. So how long is it, Kyle?
36.
36. Now, Colin, I'm thinking we have enough to find the area. Do you agree or disagree? All right, so what's my math for that?
26 times 36.
26 times 36. All right, so go ahead and solve that and tell me what you guys get. 26 times 36. Now, some of these questions on the test, you can use a calculator and some you can't. It'll tell you which ones. Duncan, what'd you get for 26 times 36? I thought I saw your hand up. I apologize. Ridley?
846.
I got something different. Angela?
Yeah.
936. Check, Ridley. You maybe just made a little regrouping error, it sounds like. So 936. All right. Oh, I did that last week. Write the wrong number, throws everything off. 936 potatoes. That's what we're talking about, right? 936 spiders.
What?
Right? 936 candy corns. 936 centimeters what, Duncan? Centimeters squared. My man. Hey, you know what makes me happy? You on task. You are doing great. I wish everybody right now was working in their workbook. That would be awesome. All right, now I got 936 square centimeters, but this problem was talking about cutting things into equal pieces. What kind of math does that sound like? I got a whole bunch of stuff and then I got to put in a lot of small pieces. That sounds like what, Kaylin? Sounds like division.
But it's multiplication.
All right, let's divide it. Let's do that as my math too. 936 divided by 9. Go ahead and solve that. Yes, sir.
Your eraser broke off my pencil.
Okay, go see Ashlyn. I have a stationery closet in the back. And then I'll send you a bill for $5.99. Really? Oh, I'm just kidding. I forgot. This is not Staples. Ashlyn, find my man an eraser in the closet. Yes, you may. All right, so where was I? I was looking for something. I see hands up. I like that. All right. So I figured out, first thing I did was I figured out the width. Then I figured out the length. Then I figured out my area. Now I gotta find out how big each piece, each area of each little piece is, if this is cut into 9 pieces. So like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 8, 9 pieces. How big is each little piece here? Colin, did you do that? What'd you come up with?
I got 104.
104 sounds right to me. Is that what you got, Madison?
Yep.
All right, so 104. Now, who can give me a sentence with an answer? A sentence with an answer, Luna.
The area of each piece is 104 centimeters.
Good. The area of each piece is 104 centimeters squared. Boom. That's a lot of work for just that. Now, what does part B say, Riley?
What are the possible dimensions of each dimensions?
Okay, so I have to think of area equals base times height or length times width. Right? So I have to do a piece and I have to have my base times my height has to, so B times H equals 104. So you have to do, oh, I can't see it. I'm sorry. You have to do like guess and check what times what equals 104. And then there could be more than one right answer, right? So I want you to just think right now, they don't want decimals, they don't want fractions. What two whole numbers can you multiply to get 104? Well, here's how I would do it if I were in 5th grade. 10 times 10 is 100, right? 10 times 10 is 100. That's really close to 104. But 10 times 10 is not really a rectangle, right? That's a square. It says they're rectangles. So I got to adjust 10 times 10 to something times something to get 104. All right, what could my guess be? Colin?
11 times 10.
So 11 times 10 is what?
110.
110. So that's too what? Too high. All right, so let's make an adjustment. We got to go lower, but not far, right, Kyle? You're close. All right, so who else has another set of whole numbers you can multiply together? Kennedy? Well, we did 10 and 10 for 100. So maybe bring one number up and one number down. 10 and 10 was exactly 100. 10 and 11 was too high. You want to guess a different pair? 9 and 10. 9 times 10 equals 90. That's too low. All right, so let's try. The other thing is, look, it ends in a 4. That's a good clue. So something times something, and it has to be a whole number, and the product has to be something that ends in a 2. Lauren?
52 times 2.
52 times 2. Let's try that. Like, my brain gets excited because I feel like that's going to work, right?
Very.
52 times 2 is 104. Those are some thin slices, right? Those rectangles are looking funny. They're 2 centimeters by 52, but they fit, right? All right, what's another one that could work, Lauren? Luna?
26 times 4.
26 times 4. Let's try that. 26 times 4. Let's see. 4 times 6 is 24, right? Carry my 2. 4 times 2 is 8 plus 2 is 10. That's 104 too. So it could be 26 times 4, unless there's rules about the slivers. What do you think? What are you thinking, Ridley?
13 times 8.
13 times 8. Okay, let's try that. 13. So wait, before we do that, let's just confirm. We're good with Luna's idea, right? Madison, you with me, huh? So 26 times 4 is 104. We like the 52. Lauren's a 52 times 2 is 104. We're doing 13 times 8 now?
Yeah.
Okay. That's 24. That works too. Now, do you think we could flip? Could we flip the heights and the widths? Could we do that and it's still a rectangle and it's the community property? It still get the same area? Should work, right? So like if I argued with Kennedy and said, no, my board, it has a height of 13.
Isn't the board supposed to be the length is longer?
Okay, the length has to be longer than the width in the original board, right?
Yeah.
So does that limit the possible answers for the pieces? I like where your head's going with that. Kayla, what were you gonna say? 21 times 4, does that work too? Let's try that. I'm running out of room. Hold on, let's think about that, Kaylin. 4 times 1 is 4. 4 times 2 is only 8. It has to be 104, right? Did we do 4 times 26 already?
Yeah.
You guys get the point, right? All right, let me stop it right there. Or did it stop already?
No.
How do you,
Did you do all plus R?
there it is.
That's